Hello, everyone. Welcome back to SAT Math Question of the Day with the Brothers Chaiken, who try to offer approaches on both studying for the SAT, Math SAT, and also doing actual Math SAT questions. Here we have Professor Seth Chaiken, PhD from Mathematics, from MIT, and he is a Professor Emeritus of Computer Science at SUNY Albany, and I'm Seth's brother Joel. I have a PhD in Mechanical Engineering from Columbia University. Okay, here we go. So, what's a good approach to study for the Math SAT is to go to Khan Academy, just Google Khan Academy SAT practice, and either take their course on the non-digital SAT or the digital SAT, depending on which one you plan to take. The digital SAT starts in the United States in the winter of 2024. What we do is we go through the advanced questions on the Khan Academy, one question a day, and we're just going to cycle through for a while, and with the idea that if we offer approaches on how to do the advanced questions, then you could go ahead and do the mediums and foundations yourself, and we strongly encourage you to do the mediums and the foundation problems yourself, as well as the advanced questions yourself. So, where did we leave off the other day? Yesterday we did linear and quadratic systems. So today we are going to do radical, rational, and absolute value equations. Okay, once we see the let's go, we're ready to go. Let's go. Okay, we have to enter the answer. And please look at the question, try it yourself, pause the video, come back, and let's go over how to do this. What is the sum of all the solutions of the given equation? Wow. When they ask what is the sum of all the solutions, we always have to ask ourselves, is there a tricky way, is there a cute way to get the sum of all the solutions, as opposed to just literally getting the two solutions and adding them? At first blush, you would think that you would square both sides. But notice that if you square both sides, you do have to ask yourself, will there be an extraneous solution? Are there going to be extraneous solutions? Which means, are there going to be answers to this equation? And I'm going to change it around 7x minus 3. Are there going to be equations to this that don't satisfy this equation? So, the sum
Wait, okay, hold on a second. If these are, if 2x squared, if this side A is equal to this side B, A and B are the same number, right?
Yeah.
So the square root of A is the same as the square root of A. And A and B are the same. So it's the square root of B. So you don't get any solution of this.
Yeah.
Is a solution of this.
Oh, you're saying that you don't get an extraneous solution in this case?
Well, is it possible to get a solution of this that is not a solution of this?
I don't know.
Right? Well, if you have a solution to this, this side and this side are equal.
Right.
Right?
Right.
Therefore, their squares are equal.
Okay.
And
I see what you're saying.
And the squares are 2x squared and 7x minus 3. Okay?
So you're
saying there are no extraneous solutions.
So you're saying by the nature of this type of equation,
yes,
it's fine.
Yeah.
So now we're just asked. Now we're going to go real fast. We asked for the sum of the solutions of a quadratic equation. The sum of the solutions of a quadratic equation is the first. Let's divide everything by 2. Divide by 2. Divide by 2. The sum of the equation, the sum of the, the sum of the solutions of a quadratic equation is the negative of the middle term. The negative of the middle term when
that's because x minus a times x minus b is equal to blah, 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 minus a plus b x.
Right.
And a plus b is the sum of the solutions.
Right. So the sum of the solutions to this problem is positive 7/2. So
Yeah.
the
Now,
answer
if you, in
here
case
is
you
7.
were, if you're puzzled about what this blah 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 is, the left hand blah 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 is x squared,
Yep.
and the right hand blah 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 is plus a times b.
Right.
None x squared is the term. X squared is not the power of x, whose coefficient is the coefficient of x. Now, the sum of the solutions, Joel said, is that when you have the equation in the form where the first in the it's called the monic form, where the coefficient of x squared is 1.
Right.
The solutions, you get the sum of the solutions by taking the coefficient of x and take the negative of it. Right? So the sum is 7/2 is the
Right.
answer.
So
for
here's
this.
just some symbols, right? This is a theta. This is a theta. The sum of the solutions equals negative theta. Now, the most efficient way to deal with this problem is to know this, is to memorize it. Seth just justified it, which is really important. You could go ahead and justify it all you want, but when you
I was just writing it out while you were talking.
Right. But when you are taking the SAT, this is something you should simply just know cold. Okay. One of the few things in algebra that we're not into, our approach is to almost no problem is to say you got to know something cold, you got to memorize something, but there are exceptions to this. And you really got to
cold. What? Cold. You have to know is cold. Yeah. 2 plus 3 equals 5.
Seth, come on.
No, that's cold. What you could do with your fingers too.
Seth, come on. Let's stop wasting everyone's
Yeah.
time.
Again, it's cold or not cold. I could see someone might forget whether the sum of the solutions is delta or theta.
Right. Yeah.
And if you forgot, well, it's either delta or theta.
Well,
so then it's a good idea to know cold this approach.
Seth, I'm going to say something.
By knowing cold what is in this green circle, you will know with a little bit of heat that the sum of the solutions is the negative of the x coefficient.
Right.
And the product of the solutions is the same sign applied to the constant coefficient. So I would rather say know the idea that the form of the quadratic equation that explicitly shows the solutions, know cold that a quadratic equation is the form of a quadratic equation that explicitly shows the solutions is x minus one solution times x minus the other solution.
Yeah, equals 0.
It's better to know that cold than to know that the sum of the solutions is minus x coefficient and the product is same sign constant coefficient.
Yeah, I guess that's always true. A and B could be anything they want. They could be radicals. They could be complex. They could be anything they want, right? Yeah. There's no limit to what A and B can be, right? Yeah. So then, I mean, Seth is basically saying, understand where the rule comes from. Because then it'll help you remember the rule. If you understand where the rule comes from, it'll help you remember the rule. But I come from the engineering approach. If you don't want to bother wasting your time understanding it right now, just know the rule. Just know the rule. The sum of the solutions of a quadratic equation is the negative of the middle term as long as there is
here's the engineering approach to building a bridge.
You build it and then you add 20% to make sure it doesn't fall.
Yeah, well, you know how to build a bridge that cold will not fall down.
Right.
You add 20%, build the bridge.
That's right. You add 20% of that.
Then you take on the project to build a bigger bridge.
Yeah.
So you make the bigger bridge bigger than the original bridge. and you make it anyway, and you know cold how to make that. You
No,
build a bigger
no,
bridge,
no,
add 15%.
no. That's not what I
Then
said.
that bridge doesn't fall down, and then you make a still
No,
bigger
that's
bridge.
not what I'm
You use the same
saying.
old principles that you know
No,
cold.
Seth,
You build a big
Seth,
bridge, and bam, it falls
Seth,
down.
that's not what I'm saying.
And then
Seth, you're
when
being
the big bridge
silly.
falls down, then you look very hard and analyze it very carefully. Why did the big bridge fall down? What did I overlook? And
Seth,
you figure it out. And
Seth,
then you build a big bridge that stays up.
Seth, that's not what I said.
Yeah. The
You're putting
engineering
words.
approach is what? Just know it cold. Know the formula code, you said.
No, no, no. This is totally just Seth. Forget. Look, no, definitely being silly. No, all I'm saying is that in certain things in algebra, it's just very efficient when you're taking the SAT to simply know that the sum of the roots of a quadratic equation is the negative of the middle term, the x term, as long as there is a 1 in front of the x squared. There's got to be a 1 in front of the x squared. Then the middle term, this theta term, this middle term is the negative of the sum of the roots. It's a good thing to know this going into the SAT. That's all I'm saying. And the delta is the product of the roots. The delta, those don't have a different sign.
Yeah.
But yes.
So notice, if the this factorization where the x is by itself here and the other x is by itself here, the product of that is x squared, coefficient of 1.
Right.
So in order for this to match the multiplied out expression, the multiplied out expression has to have one coefficient of the x squared. Yeah. Now, so they made it tricky. You had to first square both sides to get a quadratic equation. Realize that you won't go wrong that way, and then for the method of getting the sum of the roots, you need to normalize the coefficients. Put them all on one side so you know the signs, and then you divide by the coefficient of x squared to get the coefficient of x squared to be 1.
Yeah.
And then read off.
We did that already.
Yeah.
Okay, so now Seth jumped in. If I was doing this myself, I would be a little concerned, frankly, because I wouldn't have been so smart to realize immediately that this doesn't have, and it just cannot have extraneous solutions. That would always, Seth interrupted when I was doing it and said this doesn't have extraneous solutions. I wouldn't have known that. Because every time I square an equation, I always think there's going to be extraneous solutions, just to cover myself. The extra engineering approach, I just cover myself. So then I would have continued and I would have said, well, I can tell you the sum of the roots if there are no extraneous solutions, and I would say the way we did it. And then I'd sit there and I'd say to myself, I'm just going to take a chance with that answer. Because if there are extraneous solutions, then the problem would actually be too long. You'd actually have to solve this quadratic, get the answers, test each answer, and then sum them up. So I would probably at this point have just taken a chance and said, I'm just going to take a chance if I know no extraneous solutions. So I'm really interested to see what they say in the answer. Are they going to deal with the fact that this doesn't have extraneous solutions? So should we look at the answer?
Let's go for it.
Yeah, let's see what they say. First, let's, it's 7/2, right?
Yeah.
Okay, so let's do that. 7 divided by 2. Okay, so let's see if they even mention extraneous solutions. Okay. I'm just looking first. My God. They don't even mention the issue. They do. They do. They do it assuming there may be extraneous solutions because they're actually solving the quadratic.
Yeah, they did it. And
Wow.
also, yeah, they say, yeah, they did that. Yeah. But how else are they different?
How else is what different?
Yeah.
They
So
tested.
they
They
didn't
tested.
trust, they didn't they did not make a more sophisticated mathematical argument.
Wow. This is a long answer. My God, they
Yeah.
asked you that. And this is factoring using what's known as the AC method. This is not an easy factoring question by any means. Oh my God, they just say that here. Now, of course, you could do it the way Seth and I did when we were in school, as opposed to the fancier what's called AC method. You just factor this. You just take a chance. You know there has to be a 2. There has to be an X there. And this has to be a 3. And this has to be a 1. Or this one has to be a 3.
Yeah.
And they're negative. So it's going to be a -7 here, right? So this has to be a negative and a negative, right? That has to be this way, right? That's factored by brute force. But this is not easy factoring with a 2 in front there.
No.
But they therefore they had to check, right? They didn't make the assumption Seth said.
Yeah.
So let's be honest though. The argument you made as to why these don't have extraneous solutions may be above the level of most people taking the SAT.
Wow.
Yeah. But the engineering approach is just to assume, wow, so they really wanted you to solve the equation by really getting the 2 answers and adding them up.
Maybe they didn't think of a better way.
What do you mean they didn't think of a better way? Do you notice, by the way, that
a person wrote this, right?
Yeah, a person, yeah.
Maybe they didn't think of a better way. That person.
I don't know. I don't know, but notice
you could put a comment. Doesn't have why don't you put up a comment and say, hey, you don't have to work as hard. You just
where are the comments?
Don't they give you comments and feedback?
Not for the. Doesn't seem like they give you feedback for the questions. They give you feedback for the practice questions.
Yeah.
I don't know. Yeah. No, report a problem? No, we don't have.
No.
Yeah. What was I thinking? This is strange that they actually want to. So what are they doing here? Every time you square an equation, you always have to. There are cases where you will get an answer to the equation after you square it, which won't solve the original equation. It's called the extraneous solutions.
Yeah.
And what they're doing is they are assuming that there may be extraneous solutions. So they're asking you to actually solve that quadratic equation and test each answer to make sure each answer solves the original equation, which it does. Wow.
I have a cool example of extraneous solution.
Go ahead.
Yeah. Okay. I'll start out with the equation. X minus 1 equals X minus 2.
Okay.
Now, I'm going to square both sides. Right?
Right.
X minus 1 squared equals X minus 2 squared.
Right. Okay.
Right. And then I'm going to erase this. And then I'm going to multiply it out. X squared minus 2x plus 1
right
equals x squared minus 4x plus 4.
Right, okay.
Right? Did I make a mistake?
Not yet.
Now I'm going to simplify it. Subtract x squared from both sides. And let's see, bring the minus 4 to the left. So I get 6x, and bring the 1 to the right equals 3.
Okay.
And I solve it. X equals 2.
Right. Okay.
Let's check the solution. If x equals 2, x minus 1 squared equals 1 squared equals 1.
Seth,
no.
What are you doing? What are you
doing? If x equals 2.
Seth, first of all, what are you doing? If you're adding a 4x here, and you're adding a 4x here, then
Yeah.
this is a 2x equals 3.
Oh yeah, that's yeah. Let's scribble this out. So there's our side minus 4x plus 4. Now let's simplify it. Get rid of the x squared.
Right.
So we get minus 2x plus 1
Right.
equals what? Minus
4x
4x plus 4. Right? Am I right?
So far, yeah. Until you make another mistake.
Now I'm going to add 4x to both sides.
Fine.
So I get 2x and add and subtract 1 from both sides. 2x equals 3.
Right.
So that has a solution of x of 2/3.
3 over 2, right.
Now let's check that this matches.
Right.
X minus 2/3 is a third. A square of it is a ninth.
Okay.
Okay, and 2 minus 2/3, right, is how much? That is
1 1/3.
1 1/3. What's the problem?
1 1/3 squared. No, but this is the original equation. X minus 1 equals x minus 2.
Yeah.
So that's 2/3 minus 1. Oops. Oh. That's 2/3. I don't have my.
Oh no. Okay, it's a problem. Yeah. Again, math. See, we're just falling over ourselves. X is 3/2.
Yeah, x is
the answer, not 2/3. It's 3/2. So let's check this again. So we have 3/2 minus 1 is 1/2.
Right.
A square, you get a quarter.
Yeah, very good. Yeah.
And x minus 2, 3/2 minus 2. Well, 3/2 is 1 1/2. Minus 2 is a half. Yeah. You square, you get a quarter.
Right. Yeah.
Right.
But nobody cares to check the squared equation.
The original equation.
You have to check the original.
What I started with was x minus 1
right.
equals x minus 2.
Right. Yeah. So it doesn't.
So here is an example where by squaring both sides, I got one extraneous solution.
Right. Yeah, and it doesn't work.
It doesn't work.
It doesn't work. Yeah. Yeah. So that's interesting. Right. So basically, the bottom line is when you square both sides of an equation, safe to bet, as they're doing on the SAT, that you can get extraneous solutions.
Okay, Joel. Yeah, again, what's going on? I made another mistake. 3/2 minus 2 is negative a half.
Yeah, negative a half, yeah.
So what happened was I got positive a half here and negative a half here.
Right.
When I squared the two of them, I got the same thing, a quarter.
But why would anyone even? You don't check, but you're wasting your time. When you get the answer,
I'm just showing everybody an example where how to make up an example.
Okay.
Where squaring both sides gives you one extraneous solution.
Yeah, that is sort of weird. Okay. Yeah. So basically, watch yourself when you're squaring both sides. And the SAT took the cautious approach.
Yeah.
Because they actually solved it. Wow. So, Seth, I don't know what I would have done if I was doing the question myself. Because I wouldn't have known, I wouldn't have had the insight you had that this can't have extraneous solutions. So I don't know what I would have done. I'm going to be honest. Because
you could have done what they did. What they did was... Do your utmost to find solutions and then check that each solution is not extraneous.
I think I may have had to have done that.
But you could have just swept it under the rug and gotten the answer right.
Yes, that's what. But the thing is, it's inconceivable to me that now in the digital SAT, they're asking you to actually solve a full-blown quadratic equation, which you, by the way, you can use a quadratic form if you remember it. with factoring with the nodding 1 in front of the x squared. This is just so
Yeah.
amazing that the SAT may be making the test a little harder than it used to be before on the digital
Well, they,
side.
they, 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 they make it harder, so that's a good thing. Make it harder.
The other thing you could do is you could graph that thing using Desmos and pick the answers off the graph. You could do that. You could throw this thing. This is y equals. You graph the thing because you're having Desmos calculator right in front of you on the digital side. Graph it. Pick the two solutions off, 3.5, and then you have to test each one separately. Yeah. So should we quickly show how?
Well, they could have changed the 3. Where was it? They could have. If they changed that 3 to say a 2, then you wouldn't be able to factor it over the integers.
Yeah.
But the same methods that we showed will still work.
Right. Yes. The sum of the. The sum. Yes. So let's just show everyone. Last time we did this, we did not show the digital. We did not show the graphical approach. So y equals 2x squared. Desmos is so easy to use. Minus 7x plus 3. Boom. Those are the two answers. Those are the two rules. You don't have to do any factoring. 3.5. Done. Boom. You don't have to do any factoring. Right? You don't have to do anything. You just graph the thing.
Yeah, so one solution is 3, the other is a half.
Yeah,
the sum of the solutions
right.
is 3.5.
Right. No. If you don't have the brilliant insight you had, you have to check 3.5 in the original equation. Into this equation. You have to do what they did because you don't know that there may be one of those may be extraneous. So you have to actually go in and check. Like they did. Like they did in the answer.
Yeah.
Yeah, unless you have the experience with that, which very few people would have.
Well, here's another thing. Let's look at the graphical approach.
Okay. Well, the graphical approach to the quadratic.
Stop. The graphical approach.
Yeah, here's the graphical approach.
Here's.
Ooh.
Okay,
Oh.
Stop. Go back to the original problem.
Oh.
The original problem is square root of 2x squared on the left.
Oh. Yeah.
And the square root of minus 3 plus 7x on the right.
Yeah,
you could plot both of those.
No. You can do this. This is a
You can say y equals in Desmos. Let me write it out for you. Y equals.
Go ahead. You do it, Seth. You do it.
Y equals the square root of 2x squared. That's one box in Desmos.
No, just subtract.
And the other box in Desmos is y equals the square root of minus 3 plus 7x. You plot these, and what you're going to get here is a line that looks like this. Right?
Yeah.
And what you're going to get here is, when x equals 0. Now, how do you make this 0? You're going to be 0 here. It's going to be something. It's going to look something like this. And if you plot them together, you'll see
too hard.
The two solutions.
No.
And
Seth, that's a good idea. But how about this idea? Subtract.
You can do that too. Yeah.
Throw it here. Turn it into equals.
Yeah, there you
make
go.
It y. Where it crosses the y-axis, you get the stupid answers.
Aha. So one approach is this equation is true when the two sides are equal.
You're not squaring both sides here.
The equation is true when the difference of the two sides is equal to 0.
Let's do it. We're on a roll here. Let's do it. Wow, we're really giving so many people approaches. This is great. Oh my God. This is why we're here, maybe. Okay, and you're not screwing both sides. My God, look at that.
Yeah. So you want to put that in Desmos and see what it looks like?
Yeah. No, I'm just saying that if we do the other one, that silly equation you had, x minus 1 is x minus 2. My God, there's no solution to that. X minus 1 equals x minus 2 has no
That's
solution.
why I picked it.
This is why he has the PhD in math. Okay, this is why I'm lucky to be your brother.
So I have one.
Okay, now y is equal to, how do you do square root here? How do you do square root?
SQRT.
Yeah, right. SQRT. Ooh, look at
Oh, there you
that.
go.
Isn't that amazing? This is why we love Desmos. 2x squared minus SQRT in parentheses. We love parentheses, at least I do. Plus 7x, close parentheses. Hey, what happened? Oh, God, you bet. Okay, so good idea, people. Get good at get good at entering things into Desmos, because you don't want to be
You have a
floundering
double
around.
minus.
Yeah, minus 3 plus 7x. There we go. That's good enough. That's good enough. That's good enough, right? So we close that thing.
Don't do back.
No,
Yeah. Okay.
no, that just okay. Let's blow this up. Okay, there they are. Those are the two answers. A half.
So one answer is a half, and
And
the
one
other is
answer
three.
is
Is 3.5.
And this silly graph has this crazy look, which we really don't care about.
Well, I care about it. It's
No, I
it's
don't care
well, for
about it.
large x. For large x, it's approximately a straight line with a slope of the square root of 2.
Fine. And then it looks like at some point the when you get below a something, an x where x is something, then it no longer
It just gives up.
There's a problem there
Ah,
because x becomes you get the square root of something is negative.
yeah,
Um,
undefined. Yeah,
yeah. So wow, so that's a really nice approach to graph the equation when you I should always keep that in mind, everyone.
yeah,
That's the fastest way to do that, isn't it?
yeah.
Yeah. So anytime I'm driving my fingers, so you do.
But it's also also it's instructive to graph the two sides separately, and you'll see the square root, you'll see uh yeah the
Okay.
sideways parabola,
Oh God.
the sideways split parabola for the square root.
Okay. Fine. We'll do it.
Yeah.
Just humor Seth. We'll do it. Seth's dying to do this. Okay. So when these two things um are meet, those are the two. Yeah. So three. The three is over here. You have to
Yeah.
go up a little bit. You let's look at the whole thing. So
Yeah.
here we have some weird looking blue line. That's the square root of 2x squared. Oh yeah, that makes sense. It's like an absolute value thing, because y is in the plus and minus thing. X can be plus or minus, and then you have the square root function sort of moved around, and then when the two intersect is where you get the answer.
Yeah.
There and there.
And it shows that when the inside of the square root is negative, the solution doesn't exist.
Right.
So why the green.
So something
curve stops.
we really should do is we should go on our Blue Book account. I have a test Blue Book account, and make sure that the Desmos on Blue Book shows these little dots of intersection and dots of where.
Check that Desmos does this has the same power.
Right, on the Blue Book. So Blue Book is an application where it only works on Microsoft computers that Microsoft's giving everyone for free that you could test and you can do practice digital SATs on. Highly encourage you. So like if you're going to take the
Well, we should do homework and see whether the calculator in Blue Book
Yeah, we'll
is
do that.
really has the same high power as the calculator.
That's a good idea. I'll check that out. I'll check that out.
Because they may not want to give the SAT takers such a powerful calculator.
Right. It's possible. It's possible. It's possible. Yeah. Yeah. It's possible. Yeah. Do I have Blue Book on this? Blue Book. No, I don't have the Blue Book on this computer. Okay.
But I think this video gives a lesson about that. People who like mathematics and know a lot of mathematics and do mathematics, who do fumble around, make lots and lots and lots of mistakes.
Yeah.
And the trick about what we do, though, is that when we make mistakes, we know doing mathematics is something that, well, you do make a lot of mistakes.
Oh, yeah. Make a lot of mistakes.
And you have to check everything, make sure it's consistent with what you're thinking, and then check it again.
Right.
Because part of the charm is that you do these things and you will make mistakes.
Yeah.
The thing, where students have trouble is when they think that's bad to make mistakes. They make a mistake and give up.
Right. Yeah. No, mistake is a learning opportunity. A learning mistake is, we all would do. And Seth and I make mistakes. You see that we don't stop and say, well, we made a mistake. We say, well, what did we really get wrong here? And of course, we make arithmetic mistakes all the time. But we make sometimes more fundamental mistakes as well. Okay, everyone, so I think we're done. We are seriously done. I hope people got something out of this thing. There's certainly different approaches to the problem. Okay, everyone, have a great day, and hope to see you tomorrow. Bye-bye.